Okay, hello guys. Today we're talking about the three-dimensional trigonometry, okay? So let's move into the first part about three-dimensional trigonometry, okay? So first, we have to understanding what is the three-dimensional shapes, okay? So first of all, we said three-dimensional means we have three axes, right? X-axis, Y-axis, and Z-axis, okay? So we can say that three-dimensional shapes that are set in the coordinate of three-dimensional, okay? So this is the method to just trying to finding the trigonometry values of three dimension. Okay, but here I just want to show you some problems right here that will be easier for you to understand it. Okay, so let's move to the first example here. Okay, so here we can find that there is a cuboid. Okay, so we can just try to draw like here's a height h. Okay, and here's a length l, and here's a width w. Okay. So if you want to find the angle theta right here, okay, so you can using the rules like diagonal square equals to L square plus W square plus H square, okay? Why is it? Because here you can find that maybe for the triangle ABC as a right triangle, okay? So we can say here AC squared equals to L squared plus the Y squared, right? Okay. And if we have the D, okay, so we also have like here as for the like AD square equals, or you can say diagonal square equals to DC square plus AC square, okay, that is it. So you can say here equals to L square plus W square plus H square, okay, that is it. So we can say here diagonal square can be written as this way, okay. So if you want to find the angle theta, you can say that this is D, right? So sine theta equals to H over D, okay? Then you can use a calculator to find the inverse trigonometry, that is theta equals to sine inverse H over D, okay? That is a exact value of theta, okay? That is three-dimensional Pythagoreans. Okay, and here we also have another example like here, we can set like the angle between a line and a plane. We can set that here, you can just draw like PA, and here is for the theta, and here you can set like there's a line, there's a drop, there's a shadow, and sine theta equals to drop over a line, right? Cosine theta equals to shadow over the line, or the tan theta equals to the length of the drop over the length of the shadow, right? Okay, so you can just using the inverse trigonometry to find the exact value of theta, okay? So here, there's a working example for you, okay? So it's a cuboid here. We have a length, width, and height, okay? So maybe here, height is 5, and length is 8, and width is 6. So you can set here, you want to find the diagonal and the rectangular base. So that here, we can just try to draw the graph like here. So we can set here, that is for this angle, okay? So for this triangle, we can set the height is 5, right? And the like the length here is 10. Okay, so you can set that tan in the theta equals to 5 over 10 or equals to a half. So theta equals to tan in negative 1 over 2. Okay, but then you can use the calculator to calculate the exact value right here. Okay, so don't be worried about this problem. Just trying to draw the graph at first, and then you can find they're very easy to understand how to calculate the exact angle right here. Okay. So also we have another example like here, the angles in a square-based pyramid. Okay, so here you can find there's a pyramid. Okay, here's we have a height h, and we have the base here, and we can set here just using the trigonometry to find the exact value. If you know the length here L, you can set the theta of the side length with the base angle, that is the tan theta equals to h over L. Okay. So that is the thetas. Okay, so if you have the side A, and you can say that we have the a square or 2a square equals to the 2l square. Okay, so that is for L equals to 2, sorry, here's for square root over 2 times a. Okay, that is for this problem. So like examples here, we have some little bit of practice for you. So if you have your ideas and you want to draw it down yourself, you can pause the video and then just go on yourself. But if you want to follow with me, you can keep on going, okay? So maybe for the first problem, a cuboid has a dimensions 5 times 12 times 4, okay? So you can just try to draw the graph. Here's a cuboid, okay? Here's for 5, here's for 12, here's for 4. And you can set here, for the exact length of the space diagonal, you can set, you can draw the red triangle, okay? So here the height is 4, and the side here is 13, because 13 squared equals to 5 squared plus 12 squared. You can just using the Pythagoras theorem, okay? So we can set tan theta, here is angle theta, can be written as 4 over 13. So angle theta can be written as tan negative 1, 4 over 13, okay? That is for first problem. And for second problem is using the cuboid from question 1, calculate the angle between the space diagonal and the 5 times 12 base. Okay, so this is for the angle theta. And if you want to find the space diagonal, you can set that here, this is for square root 4 square plus 5 square plus 12 square, right? Okay, so that we can set is for 16 plus 169. Okay, so first problem's value is for 185 square root. Okay, that is for this problem. And for last problem is a square-based pyramid. So you can just try to draw the pyramid like here. Okay, this is a square-based pyramid. And the side here is 10, and the vertical height is for 12, okay? So first problem is to calculate the length of the diagonal of the square base, okay? So maybe here, the diagonal is a purple line, right? So you can find here, it formed a purple right angle triangle. So here, the side is 10 times square root 2, okay? This is for 10 times square root 2. And for the second problem, calculate the length of one of the slanting edges. Okay, so the edges here you can find because the square base diagonal is 10 times square root 2. So here for one is for 5 times square root 2. So the side length here it can be written as square root 144 plus 5 times square root 2 square. That is for 25 times 2 is 50. That is for square root 194. Okay, that is for second problem. And for last problem, calculate the angle between the slanting edge and the base. Okay, so you can just draw maybe here I'll draw the blue triangle. Here is for blue triangle. The height is 12, and this is for 5 times square root 2. So you can say here, the tan inverse theta equals to the height is 12, right? Okay, so you can just try to draw the triangle in another figures. Here is 12, and here is for 5 times square root 2, okay? And then you can calculate that tan inverse theta equals to the opposite side over the adjacent side, that is 12 over 5 times square root 2, okay? So finally, the theta can be written as tan in 91 and 6 times square root 2 over 5, okay? That is for theta's exact values, okay? So I hope this can help you to fully understand for how to calculate the exact values in three-dimensional triangles, okay? So sometimes they're very hard to find them, but if you're very familiar with the two models right here, one is for cuboid, another is for the square-based pyramid, okay? So they're very, very familiar, and maybe they appeared a lot of times in past papers, so they're very important. Please just to, if you have time, please just to rewrite the problems again. I hope you can just understanding them fully, okay? So that's all of this lesson. See you next time. Bye.